So as we look into the next section, let's look at some examples. So the thing that makes these different is that the leading coefficient is not a 1, and there's not a common factor that we can pull out here to make that 3 go away. So it is still going to be true that the first term comes from multiplying the first together, the last term comes from multiplying the last together, and the middle term is a combination of the outer and the inner product. The thing that's going to make this harder, though, is that since the first is not just going to be just x and x, since there's going to be a number with at least one of these, then when we multiply our outer together and our inner together, if there's a coefficient with one of those x's, then the number on the ends get multiplied by that as well. So that means the numbers on the end aren't simply just going to add to make 19. So to get 3x squared, the good thing about 3 is that 3 is prime. It's just 1 times 3, so we can have 1x times 3x. 20 is either 1 times 20, 2 times 10, or 4 times 5. One thing that we can determine, though, are signs. This one is positive, which tells us our signs have to be the same. That one tells us we need plus and plus. So these numbers have to multiply to make 20, and then our inner and our outer products have to make 19. So it's not always obvious to begin with, so we can pick a combination and try it. If we try the 1 and the 20, we could do a 20 there and a 1 there. That would make our inner product 60x and our outer product 1x. Well, that combines to make 61, not 19. So that doesn't work. But keep in mind, too, that having a 20 here and a 1 here is different than having a 1 here and a 20 here, because 1 originally was with a 3x, now 1 is with a 1x. So that might affect it. So if we do the inner product, 3x times 1 is 3x, and the outer product is 20x. Well, that still doesn't make the 19 we need, so we can check off the 1 and the 20. So let's try the 2 and the 10. So if we try a 2 here and a 10 here, we get 6x for our inner product and 10x for our outer product. So in that order, it doesn't work. So let's try the other direction. Let's try the 10 here and the 2 here. Well, that's going to make the inner product 30x and the outer product 2x, which still doesn't give us the 19. So either way, the 2 and the 10 doesn't work. So if this factors, the only other combination is 4 and 5. So let's try a 4 here and a 5 here. So that makes the inner product 12x and the outer product 5x. Well, that's close. 12 plus 5 is 17, not 19. So if it's going to work, maybe a 5 here and a 4 here. So if we try that, the inner product 5 times 3x is 15x. The outer product 4 times x is 4x. That does make the 19x we need. So our answer is x plus 5 times 3x plus 4. And it doesn't matter which factor we write first. We could write the 3x plus 4 and then the x plus 5. That would work also. All right. So let's take a look at the next one. There's not a common factor that they all have. It's good that each of these numbers are prime. To get 11, that's just 1 times the 11. And to get 3, that's 1 times 3. So x squared is x times x, and we need a 1 with one of them and an 11 with the other. Now, the only way to get that 3, we said, is 1 times 3. The question is going to be, where does the 3 go? Does it go with the 11 or does it go with the 1? So let's just try it this way. And then notice, since that's negative, our signs have to be opposite. So that also brings up another question: which sign goes with in which parentheses? So I'm just going to write it one way. And it will turn out that if we have the correct numbers, but we get the wrong sign in the middle, our signs are just backwards. So let's check. Our inner product is 11x. Our outer product, negative 3 times x, is minus 3x. Well, that makes 8x. That's not what we want in the middle. So let's swap the 1 and the 3. Let's try the 3 here and the 1 there. That still multiplies to make negative 3, but it's a different combination. So let's try 3 times 11, that's 33x. X times negative 1. Different signs, we subtract those, take the sign of the larger, so that's 32x positive. We need a negative 32x. So the only thing that we have wrong is our signs. This one needs to change to a negative. This one needs to change to a positive. Notice what that does. That makes our inner product the negative 1 and the outer product the positive 1. So now, different signs, we still subtract the numbers. When we take the sign of the bigger this time, it's negative. So if you were to FOIL that out, if you were to multiply that out, you would get this. Now this one was nice because we had only a few combinations that we had to fool with, because 11 was prime and 3 was prime. But as we run into numbers that are not prime, then we get more and more combinations. So let's take a look at this one. There's not a common factor that they all have. This one is prime. So since 5 is prime, we can do 5 times 1, and m squared is m times m. Also, let's go ahead and put our signs. This being positive tells us we need the same signs, and they both need to be positive. Now 15 is either 1 times 15 or 3 times 5. Now, let's go back and let's say something that we've already mentioned about this problem. There is not a common factor in this problem, meaning that it's not possible to pull out something in common and put it in the front. There's not a number that's being distributed to each term that we could write that as. Why is that important? Now, if this goes over your head, this is not something you have to be aware of every time, but it does save the combinations you have to attempt. So there's not a common factor here. What does that mean? That means we can't have a 15 there. If we were to put a 15 there, then this parenthesis has a common factor. And if we put that pull that common factor out, then that means there's a number that was a common factor to our whole problem. We don't have a common factor to our whole problem. So when we're testing combinations, when we're picking factors that go here and here, we can't put something in here that has a common factor with what's already in there, since our problem doesn't have common factors. That also means that if we try the 3 and the 5, we can't put a 5 there, because in that case, they would have a common factor of 5 that we could pull out, and we don't have a number we can pull out. So that keeps us from having to try quite as many combinations. So let's try the 3 and the 5. So if we try the 3 and the 5, we said the 5 can't go here. So the 3 would have to go there, and the 5 would have to go there. 5m times m is 5m squared. 3 times 5 is 15. And if we check our inner product and our outer product, That's not going to work. 3 plus 25 is 28, not 11. So there was only one way we could have arranged the 3 and the 5, and in this case, it doesn't work. So let's try the 15 and the 1. So we said the 15 can't go here, so it would have to go here, and 1 would have to go there. So the inner product is 1m. The outer product, 15 times 5, is 75m. Well, that doesn't make 11 either. You could try the 15 here, but again, that's not going to work. You could try the 5 here, but again, that's not going to work. And there are no other combinations that will give us the 5m squared here and the 15 here. So since we have tried every combination and none of them work, this one turns out to be prime. Prime just means it can't be factored. So I was hoping that one was going to be one that did factor just to illustrate cutting out possibilities, but that's okay. Not every problem factors. Okay, so let's take a look at this one. So we always begin by looking for a common factor. Is there something that goes into all of them? So, excuse me, they're all even, so 2 goes into all of them, but there's also a larger number that goes into all of them. If you take each of these into, excuse me, divide by 4, all of those are divisible by 4. So we can pull a 4 out. 20 is 4 times 5. 36 is 4 times 12. And if you don't know how many times 4 goes into 72, you could just do 72 divided by 4. That one's 18. So we pulled out the common factor. Now we need to find out how the rest of this factors. Again, fortunately, that number is prime, so there's only going to be one way to get that first term. B squared, of course, is b times b, but 5 is only 5 times 1. Since the last number is negative, these have to multiply to make a negative, so they need opposite signs. Don't stress too much at the beginning over which one goes where, because if we get the wrong sign but the right number, we just swap our signs. So I'm just going to say plus and minus. And then we need to see, well, what makes 18? There's 1 in 18, there's 2 times 9, and there's 3 times 6. So we just test combinations until we find one that will make the 12 in the middle. If you wanted to try the 1 and the 18, notice if you put the 18 here and the 1 here, 5 times 18 is going to be a big number. That's going to be negative 90. And that's going to be 1 in the middle. That doesn't work, of course. So let's try it with the 18 there and the 1 there. So that makes the middle 18, and that makes the outer 5 times negative 1, so negative 5. Now that's close. 18 minus 5 is 13, but, let's see. I've got the wrong number here. 4 doesn't go into 36 12 times. 4 goes into 36 9 times. But still, 18 and 1 doesn't work in either order. So we can mark off the 18 and the 1. If we try the 2 and the 9, if we put the 9 here, notice that's going to be multiplied times 5. So let's try to put the 2 here and the 9 here. 9 times b is 9b. 5 times negative 2 is negative 10. Opposite signs we subtract, take the sign of the bigger. Well, that doesn't make the 9 we need in the middle. we could try it the other way. We could try the 9 over here. But if we try the 9 there and the 2 there, we get 2b on the inside, 5 times negative 9, so negative 45b there, and that doesn't work. So we can mark out that one. So that leaves us with 3 and 6. So if this is going to factor, it's going to have to be a 3 and a 6. So let's try a 6 here and a 3 there. 6 times b is 6b. Negative 3 times positive 5 is negative 15b. Opposite signs we subtract, take the sign of the bigger, and that's what we need on the inside. So that is the correct way to factor that. 5b times b is 5b squared. 6 times negative 3 is negative 18. And the outer and the inner products do combine to give us the negative 9 we need. So the only other thing we need to do is bring down that 4. And that's our correct factorization. Now let's take a look at this last one. And if we were to try to do this by the method we've used on the other ones, it's what's called trial and error, where we try one and we see if it works. We try another one and see if it works. And that's perfectly fine. But notice if we try to do trial and error here, to get 20, that could be 1 times 20, or 2 times 10, or 4 times 5. 12 could be 1 times 12, 2 times 6, or 3 times 4. So there are multiple ways to get the first and the last. And when we start mixing and matching those, there become lots and lots and lots of combinations. Now, if we keep in mind that there are no common factors here, we could whittle that list down pretty quickly. And in fact, let's do that for practice. So if we were to, often what I like to do, if this number is not excessively large, I like to start with the two numbers that are pretty close together. But even if we don't do that, we could try the 1x and the 20x. So if we were to start with the 1 and the 20, then, well, which of these do we match it with? Let's get our signs. Our signs have to be the same and both positive. So if we're going to try 1 and 12, remember, we can't put a 12 here. If we put a 12 here, there would be a common factor. We have no greatest common factor. So if we're going to do 1 and 12, we would have to put the 12 here and the 1 here. Well, that's going to make our inner product really big. What's that? 240x, and our outer product 1x. So if we have 1 and 20 out front, the 1 and the 12 can't work. What about the 2 and the 6? If we try the 2 and the 6 with 1 and 20, we can't put a 2 there because that has a common factor. We also can't put a 6 there because that has a common factor. So if it's going to be 1 and 20 out front, neither way will work with the 2 and the 6. So the only other thing could be 3 and 4. Well, we can't put a 4 there. If there's a 4, that has a common factor, which we don't have. So it would have to be 3 there and 4 there. So that would make 80 on the inside, 3 on the outside, which isn't the 31 we need. So with the 1 and the 20, we've tried every possible combination to get the 12 on the end, and none of them work. So the 1 and the 20, that's not going to work. So we want to come back. We want to relist what makes 12. And then we go to the next possibility. What about 2x and 10x? Well, if we try 2x and 10x, that does make 20x squared. We can't use 1 and 12 because the 12 can't go here, common factor, and the 12 can't go here because of the common factor. The 2 and the 6 don't work either. We can't put a 2 there, common factor, and we can't put the 2 there because of the common factor. And the 3 and the 4 don't work because we can't put the 4 there and we can't put the 4 there because we would create a common factor, which we said we don't have. So without even multiplying anything out, we know that the 2x and the 10x can't work because our problem doesn't have a common factor. So if it's going to factor, it's going to have to be the 4 and the 5. So how are we going to get the 12? So if we try the 1 and 12, 12 can't go here because of a common factor. So we would have to do 1 here, 12 there. That makes 5x on the inside, 48x on the outside, which is not our 31. So the 1 and the 12 can't work. The 6 and the 2 can't work because 2 can't go here and 6 can't go here because of a common factor. So if it's going to factor, it has to be the 3 and the 4. The 4 can't go here because of a common factor, so it would have to be 3 and 4. Notice here, no common factors here, no common factors there. So the inside product is 15x, the outer product is 16x, and that does make the 31x we were looking for. So that is the combination that gives us the 20x squared out front, the 12 on the end, and our outer and inner combined to make the 31. Basically, if we were to distribute that, we would get this. So let's rework this problem using the AC method. Now for this one, the AC method, I don't know if there's an advantage necessarily on this one, but the times you often use the AC method is when there are lots and lots of different combinations to attempt. So the way the AC method works is it's a systematic process where we do step 1, then step 2, then so forth, instead of just trying things and seeing what works. So this is what's known as a quadratic polynomial or a quadratic trinomial. Notice we have x to the second, x to the first, and then a number. So in standard quadratic form, the coefficient of x squared is a. The coefficient of the x term is known as b. And then the term that doesn't have a letter, that's known as c. So in the AC method, we multiply a times c. So 20 times 12. In this case, we get 240. And notice it's positive. Positive 20 times positive 12. So similar to the problems where we don't have a coefficient in the front, we're looking for, instead of numbers that multiply to make 12 and add to make 31, we're looking for numbers that multiply to make 240 and add to make 31. So once we get a times c, what numbers multiply together to make 240, and when we add those numbers together, make that middle term, 31. So for a lot of us, that might not be necessarily an easy thing, but we can make a list of factors. Of course, it's not going to be 1 times 240, but you can take your calculator and you can say, well, what goes into 240? Well, 2 goes into 240. 240 is 2 times 120, but those don't add to make 31. Well, 3 goes into 240. 240 divided by 3 is 80. But those don't add to make 31. 4 goes into 240 60 times. That doesn't make 31. 5 goes into 240. 240 divided by 5 is 48. Those don't add to make 31. 6 goes into 240. Those don't make 31. 7 doesn't go into it. What about 8? 8 goes into it 30 times, so that's closer to 31. Does 9 go into 240? It doesn't. 10 goes into 240. That's closer. 11 doesn't go into it. 12 goes into 240 the 20 times, but those add to make 32. 13 doesn't go into it. If we try 14, 14 doesn't. If we try 16, 16 goes into 240 15 times. 240 divided by 16 is 15. Notice 16 plus 15 is 31. So these are the two numbers that multiply to make AC and add to make B. So once we find that combination, we're going to take our 20x squared plus 31x plus 12, and we're going to rewrite that 31. Instead of calling that 31x, since we know 31 is 16 plus 15, we're going to call that 16x plus 15x. We're going to bring down the 20x squared, and we're going to bring down the 12. So we just rewrote this polynomial into having 4 terms instead of 3 terms. We still have the 31, it's just written in a different format. And it doesn't matter if we put the 16 here and then the 15 or in the other order. It'll still work. Now notice what happens here. There's not a common factor that everything has, but going back to the first section, 4 terms, sometimes we can factor by grouping. So if we look at the first two, they have a 4 and an x in common. If we take a 4 out, we're left with a 5 and an x. And if we take a 4 and an x out here, we're left with a 4. Those two have a 3 in common. So if we pull a 3 out, 3 goes into that 5x times, and 3 goes into that 4 times. Notice we have a common factor between these two terms. Both terms have that parenthesis that match. So we pull the common factor out to the front. 5x plus 4 is times 4x, and 5x times 4 is times plus 3. And that's the exact same thing we got when we did it by trial and error. This is just more of a step-by-step approach to getting ones that have lots and lots of different combinations. So again, A times C, that gives us the number we're trying to multiply our numbers together and get. And then what multiplies to give us this, but adds to give the middle term. Once we find those numbers, rewrite the middle term using those two numbers, and then factor by grouping. And that will give us what we're looking for.